he had the idea because he's been to Africa a couple times, and they don't really have good medical records down there. And so this app would be for them to have some kind of electronic medical records. It was a mobile app for where you, like the doctor would log in and then you would take a picture of the patient's face. They don't really have identifiers down there either. They just carry around booklets, like paper. So it's hard to know if you have the right records.
Sure.
So this app recognizes the patient's face and then brings up their records, and you can add and edit records and do all the data entry stuff. And so that's why we actually won, because we used Microsoft Space API.
Yeah, their Microsoft Azure.
So that was that was their prize. Yeah, that's pretty much it.
Okay, well, cool.
I don't think we ended up using Firebase. Josh was working on some SQL queries and stuff for the database.
Now, what did you personally learn there? Like, what did you learn that you didn't know beforehand?
I learned about. I'm not really that familiar with Android. I know we did a little bit in that class, but the layouts and stuff I was playing with. So
yeah.
I did all the layouts for the interface. That was my main job. And I just kind of was watching them work on the database stuff.
Okay.
In the database class, so I'm just learning SQL right now.
Okay.
So it wasn't that helpful with the database stuff, but I like designing the database. I knew how to do that.
But it connected some dots for you?
Yeah.
And then using the, I assume you hadn't used Azure's SDK for face recognition stuff, so that was interesting?
Yeah, it was.
So, and you've worked with a RESTful API before?
Yeah.
Okay, but so this kind of,
HTTP requests.
Yeah. So this kind of showed you like how that same thing you did once can be applied to the same problem, just grabbing information from other things. Yeah, the one negative, even though, so I was thinking after the fact, so since, I don't know who actually put the groups together. Was it Appel or was it Curcio?
I don't remember.
So, because I didn't go to this one, it was a student-only thing, so I didn't put the groups together, because I probably would not have put the groups the way they were. Because effectively what happened is you had one team that was pretty strong, and then the other team that couldn't fit. They gave up like halfway through. They just didn't have that one, strong person who's been to several of the hackathons to kind of lead. So that was kind of unfortunate, but in any case, that's cool that you guys did really well. Another couple of things. So I want to have kind of an interesting, I want to spend maybe about 10 minutes having an interesting debate here in a second, dealing with a security thing that I had a conversation with a guy this morning that I thought would be kind of an interesting thing to talk about, because it's very related to computer science. But I saw a preview for this movie last night that I thought was just kind of very intriguing to me. And I think outside of sci-fi, this has very little to do with computer science, but it still was intriguing, so I figured I'd talk about it. So, we have this issue. How many of you have heard of the movie called Downsizing? You've heard of it? Okay, so this movie just is coming out soon, like Matt Damon's in it or something like that. But, so we have this issue in the world of, we're burning through all of our resources, we're hurting the planet, all this stuff, right? So, and we keep proposing all these different strategies for making things better. That's what we see electric cars trying to become a big thing now to, put us less crap into the air and use less fossil fuels, whatever. Well, so in this movie, the premise is that some company has perfected miniaturization. They can make a human 0.08% of their normal size. So what you do is when you commit to this, it's a one-way street. You don't go back. So when you commit to this, you effectively convert your entire life over to the miniature world. So you convert your money, like, let's say you have $50,000 in real life. That might be like $12.5 million in miniature world. Okay? And, you no longer have to live in this little tiny, this little house. Now you can live in a mansion, but that mansion is a fraction of the size of your little tiny house, because it's like a Barbie house type thing, right? A box of cereal will last you for a decade instead of a week. So that kind of thing is isn't that just an intriguing thing to think about? Just what would happen if we all could become just miniature versions of ourselves? And now think about how much slower we'd go through our...
Didn't they show them with like a giant bottle of water in the preview?
It wasn't a bottle of water. It was a bottle of absolute vodka. Yeah, they were saying something along the lines of, because you have like a big percentage of the population that's done the conversion. They've done the downsizing. And like, most of the time you just think everything's normal because you live in this whole society with other downsized people and it seems normal. Until every now and then you'll come across something like, somebody had spilled over an Absolute vodka bottle. I mean, the bottle's like the size of a cruise ship to these people. They're carrying these giant vats trying to catch the drippings and stuff. Yeah, so I'm looking forward to that. It should at the very least be kind of a fun thing, kind of a what if. What if we could do that? Would it actually help? It's showing these people, traveling, have like 300 miniature passengers on an airplane, basically sitting in one seat, just piled on top of each other. Yeah, I don't know. Very kind of fascinating.
See, it's actually just the prequel to the Smurfs.
All right, so this other thing, the computer science-y type debate. And I think this story's a little bit old, but it kind of where it's come back up recently is Amazon, I guess, just put out some big letter to, I think it's the Supreme Court, but at least it's some high court, trying to defend this. But there was some murder that happened at this person's house. And I don't remember all the details of the murder or whatever, but in any case, basically in the room where this occurred, was like by a pool and stuff like that, they had an Alexa. Okay? And apparently Alexa had recorded the entire thing. Everything that had happened. And so the police confiscated it and went to Amazon because the police couldn't figure out the case. They couldn't decide who killed who. So the Alexa had recorded all of it. All the data was there. Police wanted Alexa to release the information. The owner of the Alexa said no, so Amazon said no. Private information. What do you think?
It's a similar case to that iPhone encryption.
Mm-hmm. Yeah. What's right?
Can they just get a warrant?
I guess I don't know. Because it's digital information. That might fall under a different...
At that point, it seems like I don't remember what they call it, but you're like barring them from conducting your investigation.
Yeah. Obstruction of justice.
Yeah, obstruction of justice.
I mean, I think the short answer is no, they couldn't just do that because they weren't able to.
How is seizing that information any different from seizing like a hard drive from a company that's under investigation?
I don't know.
That's true.
But in some way it was. Yeah, I don't know the answer to that.
Well, it could be kind of like phone calls. Like you have to have two-party consent to release.
Could be, yeah. Yeah, I don't know the details behind why they weren't allowed to do it. Just, Amazon said that because of privacy concerns, they wouldn't release it. And so then the police weren't able to grab the evidence that they needed. What do you think?
I mean, that kind of like sets a precedent, though. So where if they do it once, they're going to kind of expect to do it every single time,
Yeah.
every single situation now.
It just seems like something you should be able to get a warrant for, though.
Well, regardless, I mean, just as an individual who's who both creates and uses technology, do we feel that if the information is there, if the information is accessible, should we have all the information we possibly could have in order to solve a crime?
I feel like you should have access.
Yeah.
It kind of depends on the crime because,
For
like,
murder.
even in the way they investigate things, murders are treated as like far more stuff is put towards it, and yeah, if a murder took place, then maybe. But like, if a robbery occurred and the person's like, nah, this might have private information on it, and I don't want that being recorded, I wouldn't say that they can just take that.
Yeah, I don't know. So, but doesn't it seem like it has to be an all or nothing type thing?
Yeah.
Like you can't really say, well, for these crimes it's okay, but for these other crimes, we don't care if all the details are out. And then you also have another thing about, let's assume that they blanketly release, say Alexa recordings could be used in crimes. What would then keep somebody from taking that information into consideration? And because Alexa doesn't, well, some of the new ones do, but in general, Alexa is a recorder. So what if they created an alternate scenario to throw the police off the case? You know, had a whole script they sat there and read in the room or something like that, and brought in other actors. I mean, obviously it's kind of elaborate, but you know, I mean, now you think you're getting the real facts, but you're getting a high-tech crime version of false facts or something like that. Kind of reminds me of, there was a, I want to say it was, I think it was Stargate SG-1, and there was some episode of it where they were on this planet, and this planet, they had the technology where they could effectively, you know, read somebody's mind, like, you know, rewind their brain to see everything they saw or something like that to get to the real truth. And, you know, we said, well, if you know, we suspect this person, well, we should just be able to rewind and watch their thoughts and see if what we suspect happened, right? Well, then it came out that it was that somebody had manipulated the technology, overwrote part of the person's hard drive, if you will, with the you know, an alternative representation or something. But I don't know. I find that isn't it very interesting? That's that whole thing of you know, technology. You know, it's kind of it what does Dr. Locklear say? It amplifies what's in your heart, something like that. You know, it's interesting how it can be both a help and a hindrance. So if we set some sort of precedent where we let because these recording things are all around us now, right? I mean, aren't your phones always listening at some point? I mean, any one of us can, you know, yell and your phone starts thinking. I mean, won't it, like, hey Siri, won't my laptop light up? Oh, I actually have to hit the button over there for that. But, you know, a whole bunch of people's phones would go off. Didn't we have that not that long ago with an Alexa commercial?
Yeah.
There was some Alexa commercial where a whole bunch of people's phones ordered like paper towels or something like that, because they, you know, they actually have a special way to say. They say it differently in the commercials, so it doesn't set off your Alexas at home.
That when the Xbox first came out, like with the Kinect and everything, you could just say Xbox off, and then like people's Xboxes would turn off. So if you found somebody like in a game with their like the mic output playing through their TV, you could
shut their game off.
And their Xbox would turn off sometimes.
Yeah, my buddy did that to me.
Jerks. That's kind of funny. Yeah, I don't know. This Alexa type debate is interesting because I feel like any one of us could just decide to pick a side and could argue for that side, and then the next day pick the other side and probably come up with valid arguments for the other side. It'll be interesting to see what the courts decide in terms of the admissibility or I guess Amazon being required to release that information. I just kind of found that fascinating, because usually you want things to be more cut and dry.
I feel like our group here, like as computer science students, would probably err more on the side of it should be protected than the general public would. Would you agree with that?
I guess I don't know. Why do you think that?
I think that people that are invested in technology are a lot more protective of what they have.
Well, they can kind of see the future more of like, oh,
Right.
if you do this, this is gonna happen down the line.
And also, you gotta look at it from Amazon's point of view. Like, if people like see that Amazon just willingly gives that data away,
That might hurt their sales.
It's gonna hurt the sales of the Alexa. Not many people are gonna buy
Because
that.
people, Amazon's not protecting me.
Right, and they're gonna go to the alternative, either Google or the Apple one that comes out in December.
Yeah. I don't know.
I would just think that, I don't know. I also think that it's a question of people in like the field of technology would think a lot more about that.
Yeah, it could be. But it is interesting that you say that. So it was probably correct that Amazon didn't just say yes, but it also then might be correct for the court to order that all technologies like that have to release that information. That way, you know, you either have that kind of stuff in your house where you're recording everything, or you just choose not to have that because of privacy type stuff. Yeah, I don't know, because I mean
It's
go
like
ahead.
essentially the same thing as bugging people's homes at that point.
Yeah,
Mm-hmm.
but don't we already have that? I mean, how many
Pretty much,
people?
I suppose.
How many people have either a laptop or a computer at home that has a built-in webcam? And there's all sorts of stuff out there that takes over your webcam, and people can spy on you and stuff. So, like in the labs down there, we have the little things over the camera to keep you from doing that, right? Just I don't know, interesting.
But how many people in this class have their webcam covered on their laptop?
Yeah, I don't.
I feel like as like in our field, like we know about that software, but we're still not taking the precautions to do it. So
Yeah.
it doesn't make sense.
Yeah, Dr. Wall gave a talk, I think it was last year. It was based on his dissertation stuff with security. And I guess there was a test that somebody had done where they went out, I think it was outside the NSA. So it was, a building where these people should be focused on security, right? And they dropped USB drives around, in the grass, on the, where people would find them. And something like 80% of those drives found their way into the building and plugged into computers at the NSA. Because what do? You find a USB stick, you plug it in and see what's on it. So like that's what like a normal, Joe would do, right? But you would expect kind of the NSA folks to be like ultra paranoid. I'll plug it in, no big deal.
Yeah, for senior sem, can somebody just do that in Concordia? 'Cause that would be awesome.
I mean, it would just be, yeah, it's just a really interesting thing, and almost right like you want to do it as a ethical type of approach, right? Where it grabs some piece of information from their computer that's not a security thing, but kind of evidence that not only did you plug it in, but we were able to grab some identifier from your computer proving that had we chosen to, we could have done worse. But I would be the worst.
And then if you click on
I don't have a password on half my machines.
if you click on something, the little prompt for Jurassic Park that goes
Yeah, I don't. Yeah, that would be a good senior seminar presentation, actually, for somebody to do that type of thing. It might be difficult to. Well, I mean, I don't know that you even try to get it approved. I think you just do it. But I mean, you have to do it ethically. You got to make sure what you're putting out there isn't. It's a proof of concept as opposed to taking any real information from their machine. And maybe it grabs IP address and current time or something like that, a timestamp. Something that's not destructive.
no, but grabs their credit card.
It's like, yeah, nothing's destructive. We just logged keystrokes for a month. I mean, we haven't processed the data yet.
And then your presentation is just logging onto people's portals.
Let's just go through this. So I had to write a little auto logger because it just takes too much time to manually type in all the passwords I captured. So yeah, I don't know. Interesting. Okay, so let's look at this quiz information. So we were to write a lambda calculus expression where a variable, in this case A, occurs both free and bound. Well, I technically used a capital A, so will that do it? So here's our app expression version of the lambda calculus expression. Here is that's the operand, or I'm sorry, the operator expression, the first expression. And that is our second production. It's a lambda production. It's a function that takes in a variable A. So we have bound a variable name A, and then A occurs right here. In that case, it occurs bound. On the second half of it, we have a variable A that is occurring, but it's not bound. So it occurs free. Make sense? All right, so shouldn't have been too bad. All right, so now let's go So for homework, we were supposed to look at occurs free and occurs bound. And occurs free already shows up in the book, right? Let's kind of, it's rather than copy from the book, let's write it ourselves and look at the difference for occurs bound. So occurs free is going to look for a specific variable inside of a lambda calculus expression and determine if that variable occurs anywhere in there free. Right? Anywhere in there free, not just only free. Okay? So let's back off this. Okay. So we have our cond. Now, where do variables occur? Where do symbols occur? They occur in the var expression aspect of this. Okay, so if I'm looking at a var expression, is that how I wrote it? var-exp question mark. If I'm looking at a var expression, LC expression, then and if the variable I'm currently looking at is my lambda, is the variable I'm searching for rather, then I should return true, right? As far as I'm concerned, if I'm looking through that little lens right there, where I have a var expression that happens to be the symbol I'm looking for, as far as I'm concerned, right at this moment, that guy is occurring free. True statement? Okay. So we'll go ahead and just return EQV var name LC expression. Return true if it's equal to the thing we were looking for, false otherwise. Make sense? Okay. Next, if I'm looking at a lambda expression, is that how I wrote it? Lambda exp like that? Then I'll say, if I'm looking at a lambda expression, then what do I want to boil down to? First of all, I got to consider bindings, right? So if I'm in a lambda expression and the current variable, in our case, our current lambdas have exactly one identifier for one opportunity to bind a variable, right? Exactly one, no less, no more. If the variable I'm searching for matches the variable in the binding, it doesn't matter whether or not it occurs in the next thing or not. That guy was bound. Does that make sense? Okay, so he's definitely bound. Now, but what if he didn't occur? What if he's bound here, but he never actually occurs? We already have a thing called list O occurs that tells us whether something occurs in the first place. Does that make sense? So if occurs in the first place returns a false, can't we just blanketly return false? So I'm writing this a little bit different than the book had it. So if we come up here in our cond, and we start off by saying, did we write a... We wrote a list O occurs. Did we write in occurs? Isn't that the previous class? Oh, we never actually wrote an occurs? Or did we have occurs and just expounded it to get list of occurs?
I think you were originally going to have us write it, but then you changed the assignment.
Oh, okay. So just real quick then, let's come down here. And why don't we define occurs to be a lambda that takes in a var name and an LC expression. And we want to return true if the variable we're looking for occurs, false otherwise, right? So cond var exp LC expression, then return EQV var name LC expression. So that would return true if it occurs. If we're dealing with a lambda exp LC expression, then we want to know whether it occurs in the body. So we'll call occurs on the, what was this, like lambda arrow body, something like that. How do we write it? What do we name it? Lambda expression to body, this guy. So we'll call occurs, passing it, oh, we need to pass it our var name, and passing it lambda expression to body of LC expression. So we'll return occurs on that. Else, we'll return or occurs on, what do we call it, get operator. And occurs get operand. Oh, thank you. All right, so that's occurs. So occurs tells us whether something occurs in the first place. So when we write occurs free, if it doesn't occur at all, we can just go ahead and say false. It doesn't occur free because it doesn't occur. Okay? So right here at the top, I'm going to say if not occurs. Well, actually, why don't we do this? We'll do it this way. If occurs var name LC expression, if that's the case, then we'll go ahead and do our cond. I'm actually going to do it as part of the cond. I think it'll look cleaner. It'll technically be a little slower. Let me just back off here. So we're going to say if not occurs var name LC expression. So if that returns false, that means it doesn't occur. Then go ahead and just return false. Make sense? So we'll just ask the question right off the bat. If it doesn't occur in there, return false. We're done. Otherwise, let's start asking some questions. So when I get to this thing here, I know that that guy might occur. Well, I know that guy does occur there. Does that make sense? So if I got past this first question, I know for a fact that the lambda calculus expression I'm dealing with has the variable that I'm interested in occurring. This technically is slower than doing as an if-else, because the if-else says if it occurs anywhere in here, then go through the process of the cond. Else, just do the do everything else. So I would ask the question, if it does not occur, well, if it occurs, do the whole cond. Let's look and see how it occurs. Does it occur free or does it occur bound? Otherwise, return false, because it doesn't even occur, therefore it doesn't occur free. Does that make sense? This guy would be significantly less efficient because we're actually checking on each sub-portion of the lambda calculus expression whether or not the variable occurs at all in that sub-expression. I can't decide which looks better. There's option 1. If occurs var name LC expression, that's true. Do all our con stuff. Else, return false. Like that. So this guy says if we're looking at a lambda expression, we would only be in here if we have a situation where it definitely occurs. Okay? So then what we're going to do with a lambda expression is we're going to return, call it lambda expression to body. So if we're looking at a lambda expression, then go ahead and return occurs free, passing it our var name, and passing it lambda expression to body of LC expression. So whether or not it occurs free in the body. Else, we're dealing with an app expression. And we want to know whether it occurs free in the operator or the operand. That makes sense? So, or occurs free var name get operator LC expression. Occurs free var name get operand LC expression. All right, so this returns true if this variable occurs free in this lambda calculus expression. Very first thing we ask is, if it occurs in here, then let's find out if it occurs free. Otherwise, just return false. It doesn't occur, therefore it definitely doesn't occur free. And was the book's definition of occurs free, was it only occurs free, or that it occurs free somewhere? My big question here is whether this should be an or an and. Huh? It's an or. So if it occurs free anywhere in there. So we could have a situation like our quiz today where the left-handed occurs bound in and the right-handed occurs free in. And this guy should return true because, yes, it does occur free somewhere in there. All right? So that's occurs free, probably written a little differently than the book wrote it, but it should be similar enough, right? What about occurs bound? Well, occurs bound, we, again, only want to do this if it occurs. So if occurs var name LC expression, then we'll go ahead and do our cond. We're going to ask, is this a var expression? If yes, what do we do with a var expression if we're trying to determine if it occurs bound. What happens if I see a variable that matches the variable we're searching for? At this point, do I know whether I know it occurs, but do I know whether it occurs bound or free? So at this level here, the best I can do is answer no, false. This does not occur bound because I'm looking at a very tiny picture of this. I see it occurring, but as far as I'm concerned, it's not bound. Does that make sense? Okay, so for right now, let's return false. So we're going to return not, well, actually it should be if the var name and the LC expression match, that means it occurs, but not necessarily free. So we'll return false. If it doesn't match, then we'd also return false. Right? It doesn't match, it doesn't occur at all. Does that make sense? So as far as what I know right here, wouldn't I always return false from a var expression's perspective? As far as I know right now. We're going to have to make a decision on how we're going to write this. And I think occurs is going to help us. All right, so for right now, we're just going to say, look, all I have to look at here is a var expression. Whether it matches the guy you're searching for or not, I know nothing about bindings at this level. So I'm going to go ahead and return false. Now, if I'm dealing with a lambda expression, LC expression, now I can figure out bindings. Okay, I have some information about bindings. All right, so what am I going to do with that information about bindings?
Check if the identifier and the bodies what we've been calling are equivalent, and if they are equivalent to the variable we're searching for.
Okay, well, but the body might not be a var expression.
Yeah.
The body might be a lambda expression that maybe then it has a var expression in it. But wouldn't it be bound by this level? Because now we're starting to get into the scoping rules, right? So what do you think? How'd you write this? How many of you wrote this using our environment as a part of the helper? Couldn't you have done that? Couldn't you have gone ahead and every single time you find a new binding, you go ahead and add that to your environment and then pass the environment into maybe a occurs bound helper? And when you find a variable expression, you ask, is it in my current environment as it currently stands? If it is, that means it was bound. So every single time we run into a new identifier, we have an extend env of the current env with our brand new identifier in there. So we could have written it that way, couldn't we? Actually leverage our environment for looking it up. So nobody did that. Interesting. Okay. So how else could we do this?
Have a helper function that calls a list of bindings and then just check it against that list.
Okay, possibly. Okay. Let's think about this. When do you call list of bindings? Because is it good enough to get list of bindings on our entire lambda calculus expression? And then say, oh, we'll just pass that list around, and if it's bound in there, and we find it here, it must be occurring bound? Is that necessarily true? Or might it be bound somewhere in that list of bindings, but it actually didn't occur under the scope of one of those bindings? Because listo bound shows the list of all the variables that are bound somewhere in a lambda calculus expression. So it's going to give you the list of the stuff from the left and a list of stuff from the right. Well, if you're looking at a variable that occurs on the right, and you accidentally decide that it must occur bound because it was bound to a variable that was found on the left, isn't that a problem?
Yeah.
So it's kind of a scope type thing, right? So if you don't want to use the environment itself, we really need to have like an occurs bound helper. So we're going to call this our helper because that'll make life easier, so I don't have to rewrite this stuff. And we'll go ahead and we'll say, that guy's complete, isn't it? So we'll define occurs bound to be a lambda that takes in a var name, an LC expression, and a cur binding list. Actually, this guy's going to be one that takes in the cur binding list. And then what this dude will do is he'll call occurs bound helper, passing it the same var name, the same LC expression, and then the current list of bindings in this particular, well, initially we have nothing bound, right? So this is going to effectively be a list of scopes. Now we want to be able to search through a list for a variable name to find that if it's in there, right? So then we also need to define list contains lambda var name and a list if null list boil down to false, else if car LST is equivalent to the var we're looking for, return true, otherwise return list contains on the cdr. List contains var name and the cdr of the list. All right, so that's going to return whether or not a list contains an element, right? So then we come here, and I know we're out of time here, so let me just patch this up real quick. Okay, so when we come here, if we are looking at a var expression, we want to return, this guy should say occurs bound. So we want to return true if we found a variable that occurs right here. We know it's a variable that definitely occurs, but it's also found in my list. So we're going to return the result of list contains var name and cur this is, we only want to do this if they match. So here, I'm just going to leave an error right here. So we'll pick up there next time. Now, let me just toss you a, actually, let's do this. Because we're kind of at a breaking point, read ahead. I won't give you a homework assignment for next class, but go ahead and read ahead to page 50. That'll introduce kind of the next piece to us, okay? And I'll say be prepared for a possible quiz next class dealing with the material from where we currently are to page 50. All right, I will see everybody on Wednesday.